Another type of nuclear reaction is nuclear fusion. So there's fission, which is splitting apart, and fusion is putting things together. And if you think about, fusing two things, you're gluing them together, right? You're fusing them. So that's how I remember. Nuclear fusion is taking two smaller nuclei and combining them together into a heavier one. Both of these reactions, fission and fusion, are highly exothermic. And if you're wondering where does that energy come from, the daughter nuclides that are formed have greater binding energy per nucleon, and that's where the energy comes from. Fusion is the energy source of the stars. Have you ever wondered about the sun? How does it just keep glowing like that? And I mean, it's really far away from us, but it's hot. The sun's light and energy comes, and it's hot. How does it do that? It just keeps going and going and going. It's nuclear fusion, the combination of two lighter nuclei to make a heavier one. So that's the energy source of stars, and it's the basis of the hydrogen bomb. Fission is used in an atomic bomb. Fusion is used in a hydrogen bomb. The hydrogen bomb has up to 1,000 times the explosive force of an atomic bomb. I mean, atomic bombs are mind-bogglingly powerful. A hydrogen bomb is 1,000 times more powerful. So what happens in a hydrogen bomb? It involves hydrogen. So hydrogen has 3 different isotopes. Tritium has a mass number of 3 because it's got 2 neutrons and 1 proton. Deuterium has a mass number of 2 because it has 1 proton and 1 neutron. And what we think of as normal hydrogen, protium, just has a single proton in the nucleus. It doesn't have any neutrons. Protium doesn't do much of anything, but if you get deuterium, tritium and deuterium, and you combine them, they will form a helium-4 nucleus and a neutron. And so you combine these two, and you get a neutron and a helium-4 nucleus. What else do we call this? Alpha. This is an alpha particle. So it gives off alpha rays. So how do you get this started? You use an atomic bomb to start the hydrogen bomb. So you just need a small atomic bomb, a fission bomb, to generate the very, very high temperatures necessary for this reaction to occur. Once you get this started, kaboom, the fusion reaction is tremendously powerful. There are a lot of people working on how could we use nuclear fusion to generate power? Because this gives off less waste than nuclear fission. We get 10 times higher energy density, and the problematic products are fewer, so there's less bad waste to deal with. The major problem is, what are you going to put this reaction in? It generates such high temperatures that it vaporizes all known substances. You cannot contain it in an iron box or a titanium box or anything like that. Lead shields, concrete, just vaporizes them. So one of the things they're working on is possibly using magnetic fields to contain the reaction. So people are working on it. Have they succeeded yet? No. Maybe someday.